From a distance, a modern oil field at dawn looks almost entirely still, but beneath that quiet surface is a volatile physical reality. Every single second, the equipment here generates millions of raw data points, fluctuating pressures, spiking temperatures, and subtle shifts in vibration. For decades, human operators managed this complexity through a fragmented system, relying on individual spreadsheets and delayed paper reports that rarely showed the whole picture at once. This created a dangerous lag in communication. An operator might notice a slight pressure drop in one report, but by the time they connected it to a vibration reading from another department, a pump seal had already blown. OmniPetro bridges this gap by networking the entire physical infrastructure into a central digital hub, providing a live map of every operational variable. Modern energy production requires moving away from this reactive model, replacing guesswork with total operational visibility to prevent downtime before it begins. To see how the system functions, we can follow a single data point. In the field layer, sensors act as mechanical senses, picking up a specific microvibration on a single field pump. That vibration is captured instantly, joining a massive stream of signals gathered by drones, SCADA systems, and sensors that monitor the real-time heartbeat of every asset. This raw noise moves into the communication layer, where it is cleaned and standardized into a uniform operational format. But data is only useful if it reaches the right person. Instead of flooding every terminal with millions of signals, the system applies a strict routing logic. OmniPetro customizes these feeds, routing well performance to production engineers and isolating specific vibration metrics for the maintenance teams who actually service the hardware. The goal is to filter the noise so that every specialist sees only the specific, verified facts they need to make a decision. These filtered streams eventually converge in the data core, the central processing hub where every signal becomes part of a unified source of operational truth. By cross-referencing live feeds with historical logs, the data core builds a digital twin, a real-time 3D replica that reflects the exact state of the physical field. The AI core monitors this digital replica around the clock, looking for patterns that a human eye might miss. When the system links that initial microvibration to a subtle pressure drop, it recognizes a pattern of impending failure based on years of historical data. The AI flags the anomaly, generates a predictive warning, and suggests a specific mechanical fix before the equipment sustained any physical damage. By shifting the facility's timeline, the system allows the crew to prevent a breakdown rather than reacting to a shutdown. Returning to the field at sunset, we see a facility running at peak efficiency because every potential disruption was handled before it manifested. OmniPetro has transformed a collection of disconnected metal and sensors into an integrated network that anticipates its own needs. In an industry defined by thin margins and high physical risk, this level of predictive insight is the difference between steady production and a catastrophic month-long shutdown. But identifying a problem in the digital model is only the first step. How does this digital system actually intervene in the physical world to stop a mechanical failure in progress? That is what we'll explore in our next episode.